So I thought it was useful to start with some of the best links to find out about what mathematics is like at university, what mathematics is like, and its applications in the careers that are on offer to a mathematician. And you will rarely find these careers advertised as seeking a mathematician, hence why it's useful to go through some of these slides about where mathematicians are employed, who employs mathematicians, the kind of skills that they are seeking, some CV tips, and I definitely recommend Maths Careers website. It's got a plethora of things to excite, plus lots of activities and some competitions, including ones where you can win things like iPads. So well worth a look. So people ask, well, what kind of careers do you go into if you have a mathematics degree or a mathematics and some other subject degree? And the answer is many. You might go into engineering, you might go into risk, finance, you might go into even computer games, CGR, you might go into defence. So this is a good representation of what the members within the IMA do as a pie chart. You can see some are in education, some are in government, IT, communications, defence. And to give you an idea of the type of employers, you've got Rolls-Royce, DSTL, Vodafone, the NHS, government, NASA, British Gas. Tesco's has a large analytics section. So really a lot of companies do employ mathematicians, but you will often see it advertised as them wanting a data analyst or maybe a computer modeler. So I encourage you to really look at the skill set that they are after. And some of the employers are what we call corporate affiliates of the IMA. That means that they have accredited training schemes for graduates. So you know that when you're going to them, you will get a really good experience, that they will invest in you and your professionalism. Okay, so what if you want to go into research or academia rather than going into industry? Well, I highly recommend the Maths Matters series to have a look at. Everything that is an application of mathematics, an impact that we've come across as the IMA. We've written little descriptions of, originally designed for politicians, but a really good introduction to the various areas that can whet your appetite, if you like. What kind of skills do you need as a mathematician? So the ones I put in black, you might have thought about already: the independent learning, independent working, but you may not have associated them with a mathematics degree or qualification. You might think of those more as problem solving or analytics or numeracy, but actually those skills in black are just as important, if not more so. The ability to work in teams, good programming and IT skills, knowledge transfer, all of those. So I would encourage you to build your CV, look for opportunities to build your technical strengths and show your interest in mathematics. That might be by summer studentships, it might be internships, might be working for charities or doing STEM outreach. Opportunities that show that you're doing teamwork, that you're doing programming, that you're working in applying your problem-solving abilities. And if you're wondering what mathematics is like at university, then again, the Maths Careers website has this booklet for you. So where do the IMA come in? Well, the Institute of Mathematics and its applications are a professional body that support mathematicians in industry and academia, and they have an E16 plus newsletter that you can enroll on for free. So just register here and that will be available to you. Okay, so now switching gears a little bit, I'm going to talk through Dr. Zahra Chamberlain's slides. So Dr. Zahra Chamberlain is the president of the IMA at the moment. It is my honour and privilege that I've been lucky enough to work with him as time on the IMA Council and also during the Professional Affairs Committee meetings, and you will not meet a more enthusiastic and knowledgeable mathematician. These are just some of the accolades that you can see on my screen. So he was the first Black mathematician to enter Who's Who. He was number 3 on the Power List 2019, and he has even won Most Interesting Mathematician on YouTube, which was an excellent, fun competition a few years ago where they posted different movies and he won. So any opportunity you get to listen to a talk by Zahra, please do so. But Zahra would point out that it wasn't all plain sailing. He met obstacles at the start of his mathematical journey. Some careers advisors and teachers told him, well, he should be a boxer, not a mathematician. And good for Zahra, he went home and he talked through with his family, and his mum told him, you don't need anybody's permission to be a great mathematician. Now, if Zahra was here, he would ask you each to stop and reflect on what that statement means for you personally. You don't need anybody's permission to be a great mathematician. So that's where he started, and he discovered the attitude. He discovered the wonderful network of mathematicians who are not normally the person who gets the best exam marks at the top of the class. They're often the people that are the most dogged and determined and persevere with problems. They just love trying to apply their knowledge to solve real life situations. And he's been doing 25 years of mathematical modelling all over Europe. So you can see he's worked on helicopters, airline, he's worked with aircraft carriers and Formula One. So just as an example, so we'll see 2 examples from him. The first one is the future aircraft carrier. So he was approached by a Navy officer who said, Zahra, you have to help me. I don't think this aircraft carrier is going to be viable if I build it. It's going to cost too much to run. And Zahra went to the board and he said, I can solve this for you. And these somewhat stuck in their ways engineers told him, well, no, you can't. Maths isn't for this kind of a problem. And he said, well, yes, you can. This is actually the Goldilocks problem. You don't want something that costs too little and you don't want something that costs too much. You want something in between. So he used network theory to solve their problem. And the result, 10 years later, was the launch of the HMS Queen Elizabeth. This wouldn't have happened without Zahra and the other mathematicians. So it will carry a plaque inscribed with the names of those mathematicians that made this happen. So this is just one of his examples. We're now going to go on to the second example, which we actually have a movie, which Keris is going to share. Keris, over to you, please.
The second case I'm going to talk about is the problems with bearings, and this has to do with Formula One racing. Now, what occurred here is I wanted to go and work over in the Netherlands, but my as a secondment. But my boss has said to me, well, because I think I was approaching the age of 30, and my boss said, well, really and truly, you shouldn't go because mathematicians hit their peak when they are 21. And I said, look, I'm still sure that I've been working, doing mathematics. So I've never stopped learning. So I'm sure that I'm still just as good as I was when I was 21. So now here was the problem: was what you have is that you had the wheels which was connected to the main chassis, but if the bearings was created too much friction, what could occur is that you have some lock-in, and that the wheels could actually fly off. And so I said to my boss, so we'll send me to the Netherlands because I used to work with the competitors, and I'm sure that I can actually work out a way actually solving this problem. So, but what they're saying is that, and this is again, we'll say engineers working in an engineering environment, they say that there are problems which are too complicated to be solved by mathematics. I said, well, let me have a go, let me have a look, let me see what I can do. And so again, this was to do with the Reynolds equation, and again, the Reynolds equation is something that engineers believe is in their domain. Because even though it is a partial differential equation, they believe that this is that resolves in their domain because they have the engineering knowledge how to apply it. So, but one of the things I realised is that the problem is that the bearing company had come up with a simulation, and then the Formula One company had come up with a simulation, but the two algorithms were incompatible to each other. So one of the things that I was looking at is they said to me, well, Nora, is there a way of actually just changing the code, the code, so it would be made compatible to the Formula One simulation? So I was thinking, well, what is the quickest way of actually changing a computer code? And I thought, well, the quickest way is to write a computer virus. And I thought, well, isn't computer viruses usually evil? I'd say, well, now what happens if I write a computer virus that actually will go into the bearings simulation and then converts it and make it compatible with the Formula One simulation, and then put it and then embed it in so that you would have just one simulation where it would actually work out the bearing simulation embedded within the Formula One simulation. So we did that, and that was like a 6 weeks project because that was in the middle of the Formula One season. And writing this virus actually worked. And what occurred was the Formula One team that we was actually working for, our client, actually went on to win the championship that season.
Fantastic. So that was the end of Naira's piece. Now I'm going to take control again to share the slides again. So going on to Zahra Cader, who unfortunately again can't be with us tonight, but she's Senior Analyst in Transportation. I met her last year at the Early Career Mathematicians Conference, and she was in the process of working towards her chartered mathematician status with the IMA, which she successfully achieved last summer. So she started with a BSc in mathematics. She works on a number of committees, so she doesn't just work for her industrial company, which is Atkins. She's a member of the Institute of Mathematics, and she's also a member of the Institute for Asset Management, and she's a STEM ambassador. So she works as senior analyst programmer in the digital asset management transportation. So she wanted to share with you her typical day. And her typical day, so starting from the bottom left with the Road Authority's asset valuation system, so she accrues data across a number of sources, and that tells the government how things like bridges and roads are degrading. And that allows the government to work out how much money it puts into the pockets next year to actually be able to repair those assets. She's also shown you some of the tools that she uses, including SQL, which is a database language. And what she's doing is pulling together different types of data. So some of that is things like heart rates and speeds of cars and maps. So she then can create Power BI dashboards, which is a Microsoft tool, and she also uses the Python programming language to do this. And one of her most creative projects was to capture data about drivers' stress levels. So they used statistics, they had measures on the drivers to measure their heart rate and to measure their eye movements, and measures on the car to measure the speed that the car was going at, and then cameras to see the location of the road. And from this, they could highlight what was stressing out the drivers on motorways. And by fusing all of this data together and using good data analytics and mathematics and machine learning and AI, they were able to identify that often near roadworks, the speed limits were too low and they were too close to the speed limits of the lorries. And this was stressing the drivers out because they were driving at the same area of the lorries and they couldn't just overtake. So she also managed to identify with this where to put the signage on roads so that that could be moved. And they were able to start a campaign to avoid tailgating. So all of that came from the mathematics involved in her role and using it creatively with real world problems. And her highlight of her career is that she actually presented this on BBC Breakfast. So here you can see her with her graphs explaining. So other highlights she wanted to tell you about are hackathons. So some charities run hackathons, some institutes, some schools, some universities, some are studentships. And these are great opportunities to work with a team of often a range of expertise. So some programmers, some mathematicians, maybe some application specialists like engineers or physicists or biologists. And their question in her case was, how can digital technology be used to manage autonomous vehicles? But it's a great way to increase your coding knowledge, to challenge yourself and to get used to working in teams. And it's also worth noting for your CV that many companies might ask you to do a hackathon style experience if you're applying for an IT or programming or data analysis role. So a good thing to get as experience under your belts.